Hello friends, I welcome you in lecture number 16 on logic. In this lecture we are going to discuss that how we can obtain conjunctive normal form of a given formula. We have discussed the method of finding disjunctive normal form in previous two lectures, and for finding CNF method is same, but we remember that CNF is nothing but product of elementary sums and DNF is nothing but sum of elementary products. So for DNF we will try to convert our formula in this form, that is we have OR operator and all these products are linked by OR operator, and in conjunctive normal form we have elementary sums here and they are connected by AND operator. And what we have to take care is that we allow only negation, disjunction and conjunction operators in either CNF or in DNF. We do not allow negations outside the bracket. So if we have this type of thing, then we can use De Morgan's laws to take care of this type of negations outside the brackets, and then we use distributive laws of logic whenever required. So with this in mind, we try to obtain conjunctive normal form of a given formula, and we will understand how we can obtain required CNF. So again we start by definition of CNF. CNF is nothing but product of elementary sums. Here we have elementary sums. Elementary sum is that type of sum in which we allow variable and their negations. For example, P or Q is elementary sum, negation P or Q is also elementary sum, and we can write several examples for elementary sums. All these are examples of elementary sums. So elementary sums means variables and their negations are connected by OR operator or disjunction operator, therefore they are called elementary sums. And CNF is nothing but elementary sums linked with AND operator. So we try to convert this formula in CNF. Here we can see we have P and in the bracket P implies Q, but we do not allow implications, so we will replace P implies Q by its logically equivalent form, which is negation P or Q. We have discussed in earlier lectures that P implies Q is logically equivalent to negation P or Q. Therefore, we can replace this P implies Q by negation P or Q. Now we can see here that this is nothing but elementary sum. We have negation P or Q. We can consider single variable as elementary sum as well as elementary product. So here we will consider P as elementary sum. So we have two elementary sums, variable P and this negation P or Q, and they are connected by AND operator. So this is nothing but conjunction of elementary disjunctions or product of elementary sums. In short, we have expressed our formula in this form, where we have two elementary sums which are P and negation P or Q, and they are connected by AND operator. Therefore, this is in conjunctive normal form, or we can write that which is required conjunctive normal form of given formula. So this is the simple example in which we have written given formula in conjunctive normal form. Now we consider another formula and we try to write it in conjunctive normal form. Here we have negation P or Q if and only if, that is biconditional statement P and Q. So here also we recall this double implication, or R if and only if S. This is logically equivalent to R implies S and S implies R. What is meaning of this? R if and only if S. So this is true if R implies S and S implies R. So we can remember in this way. So now we can see here, instead of R we have negation P or Q. Here we have P and Q. So in this formula we consider this equal to R, this equal to S, and we can write it in this form. So I can write that this is logically equivalent to R is negation P or Q. This implies S, that is P and Q. And in between we have to write AND operator. And now I write S implies R, that is P and Q implies negation P or Q. This first statement implies second statement, that is negation P or Q implies P and Q, and second statement implies first statement. And in the bracket we can mention whatever we are using. Here I can write that using this R if and only if S, this is logically equivalent to R implies S and S implies R. So using this we are able to write in this form. So given formula is written in this form. But we can observe that still we have implications or conditional statement. So conditional operators are not allowed. So now what we can use is, we can use this logical equivalence. We know that P implies Q is logically equivalent to negation P or Q. So that we will use for both of these conditional implications. So again we understand this. P implies Q means negation of first statement or second statement. So here my first statement is negation of P or Q, and I have to write its negation. So negation of negation P or Q becomes P or Q, that I am writing directly. P or Q, or second proposition, that is P and Q. This is for first bracket. Negation of first proposition, that is negation of negation P or Q, that becomes P or Q, or second proposition as it is, that is P and Q. Now we keep this and as it is. Now here we use this again. So here first proposition is P and Q, and we have to write negation of P and Q, or second proposition as it is. Second proposition here is negation P or Q. Now we can see we have only AND, OR and negation operators. And now we can observe here that negations are outside the bracket. Same thing here. So using De Morgan's law we will write equivalent formula for both of these. And here we can see we have P or Q or P and Q. So for this we can use distributive law, and we want to find out conjunctive normal form. Therefore we are using distributive law in this way. I consider P or Q, and P or Q or P. I consider first P or Q with P, that is I am writing in this way, P or Q or P, and this AND operator I am writing in between. Then I will consider P or Q or Q, P or Q or Q. So this is using distributive law. We can consider P or Q equal to say Y, then we have Y or P and Q. This we can rewrite as Y or P and y or q, and then we replace y by p or q, that is p or q or p, and y is p or q or q. So this is using distributive law. If you are not comfortable, you can assume that suppose p or q equal to y, and then you can write in this way. Now for second portion, here and as it is, now I am using De Morgan's law here. Negation of p and q will become negation p or negation q here, or as it is, and negation of p or q will become negation p and negation q. Now this is equivalent to we can keep this as it is. We can observe that this is elementary sum. We have variables connected by OR operator. Here also this is elementary sum. So we keep this as it is, p or q or p and p or q or q, that we have written by applying distributive law here. And now here I have to apply distributive law again, so you can understand in this way. Negation p or q, that I will join with negation p and I will keep OR operator in between. So first part is negation p or negation q or negation p, or we can write in the bracket. Then we write AND operator here, and then negation p or negation q is connected with negation q by OR operator. So let me write negation p or negation q or negation q. AND operator we have written in between. Again we repeat, negation p or q or negation p, this OR is used here. Similarly negation p or negation q or negation q, and this AND operator is in between. Now we can observe that this is also elementary sum. We have variables and their negations connected by OR operator. This is also elementary sum. Therefore we can remove this bracket, and we can observe that we have conjunctive normal form. We can see that all these are elementary sums and they are connected by AND operator. Therefore this is in conjunctive normal form. So we can easily write down given formula in conjunctive normal form. First, what we have done, we have replaced this biconditional formula or statement by its equivalent form, and then we have replaced this conditional implication by using this logical equivalence. After that we are using distributive law. So we can write in the bracket here we are using distributive law as well as De Morgan's law. Using distributive and De Morgan's laws, whatever laws you are using, that you have to mention in the bracket. We consider one more formula. This is not in conjunctive normal form. We can see we have OR operators here, and here we have AND operator. We want to express our formula in this form, not in this form. We have conjunctive normal form, so we have AND operator, and here we have elementary sums. So elementary sums which are joined by conjunction operator. So how to convert or how to write equivalent conjunctive normal form for this formula? So here we consider q as it is, and you can observe for this second part, you can see we have P or negation Q or negation P and negation Q. So this I can rewrite as, you can see we have negation Q common here and it is connected with AND operator, and this P and negation P are there, and in between we have OR operator. So this I can rewrite in this way, P or negation P and negation Q. Now you can again apply distributive law in reverse direction. You can see if I apply distributive law here, then what I will write, P and negation Q, that is here, or in between negation P and negation Q. So using distributive law I can write this in this form, so that we are writing here now. This is just to explain that how we can use distributive law if we have this type of form. So again I repeat, here we have negation Q, that is with AND operator, in between we have OR operator. So this is logically equivalent to P or negation P and negation Q, and this I am writing in bracket, and this I have written using distributive law. Now this I keep as it is, Q or. Now here again I can apply distributive law. I will not write Q as it is. Now I want to express my form in this form, AND operator in between, and here we have elementary sums. So now I can use distributive law. I can write Q or this, that is Q or P or negation P, AND operator Q or negation Q. Okay, I am applying in this way, Q or this first bracket, that is P or negation P, AND operator, this AND operator here, and Q or negation Q. And here we have OR operator, and using associative law we can remove the brackets. So this becomes elementary sum, AND operator, this is also elementary sum, and here also I am using distributive law. So now you can see this is elementary sum or elementary disjunction, this is also elementary disjunction. They are connected by conjunction operator, therefore this is in conjunctive normal form. So we have to be careful while applying this type of distributive laws, and we have to keep in mind the form of conjunctive normal form, so that we can use appropriate laws to arrive in this form. So in this way we can obtain conjunctive normal form of a given formula. So this is all about this session. I hope you like it. Thanks for watching.